Now let's see what is meant by frame allocation. See, what is meant by frame allocation is number of frames which we are going to allocate for a particular process is called as frame allocation. See, you know what is meant by frame, right? Our RAM will be divided into frames. Our process, let us assume the name of the process is P1 and it has been divided into pages, and also we know that page size will always be equal to frame size. Now, see, one thing is for sure. Can we load this complete process into the RAM? See, this process has 7 pages, right? Page number 0 to page number 6, so it has 7 pages. Now, can I load all the 7 pages inside the RAM? In case if I do that, I am not actually making use of the concept named as virtual memory, right? What is meant by virtual memory? Having only few pages of a process. Now, why are we going for virtual memory? Which means why are we maintaining only few pages of a process rather than maintaining all the pages of the process? The reason is, in case if I maintain only few pages of a process, I will be able to allocate more number of processes inside the RAM, right? Which means the degree of multiprogramming will actually increase. Now, in case if degree of multiprogramming increases, our CPU will be left out with more number of processes to execute, which means it has a lot of choice, right? Now, so because of this, what will happen is the CPU efficiency will increase, right? We have already seen it. So by using virtual memory concept, degree of multiprogramming is going to increase, and if degree of multiprogramming increases, CPU efficiency is going to get better. So that's the reason we will not be placing all the pages inside the RAM, right? Now, how many pages should we place inside the RAM, right? That depends on how many frames are we going to allocate for this process. Let us assume we have P1, P2, P3. We have 3 processes, right? Now, for every process, we will be giving some fixed number of frames. For example, for P1, I'm going to give that you can use only 3 frames. For P2, I'm going to give you can use 2 frames, and P3, I'm going to give you can use 3 frames. Now, if this is the case, then process P1 cannot use more than 3 frames, which means among these many frames, process P1 can use only 3 frames. It cannot use more than that, right? Similarly, process P2 can use only 2 frames. Process P3 can use only 3 frames. This is what we mean by frame allocation. The number of frames I am going to allocate for a particular process. See, here the 3 frames are allocated to process P1, right? Now, how will this happen? See, let us assume these 3 are the frames which are allocated to process P1. These 3 frames, right? Now, how our CPU will execute this is, it will load some three pages of process P1 over here. For example, let us assume it has loaded page number 0, page number 1, and say page number 5. Okay, these pages it has loaded. Now, in case if it wants to execute page number 2, which means our CPU has referred for a byte in page number 2. Now, what will happen? There will be a page fault, right? Because page number 2 is not present inside the RAM. So, what we will do is, we will replace one among these 3 pages with page number 2. Right. So we need to replace one among these 3 pages with page number 2, right? Now, which page are we going to select? See, the process of replacing one among these 3 pages with page number 2 is what we mean by page replacement, right? See, we cannot place page number 2 over here. Why? Because already 3 frames has been utilized for process P1 and only 3 frames has been allocated for process P1. So you cannot use more than 3 frames. Now we are supposed to use only 3 frames. So what we will do is, we will actually swap out one among these 3 pages. What is meant by swapping out? Moving from RAM and then placing it in hard disk, right? That is what we mean by swap out. Now, which page should we replace? That is what we mean by page replacement. Now, the process of deciding, now how will we decide which page to replace? That is being taken care by page replacement algorithms, right? We have already seen it little bit, which means in case if I use first in first out page replacement algorithm, I will replace the page among these 3 pages. I will replace the page which has reached the RAM first, which means which has arrived to the RAM from hard disk first, using the arrival time, right? Which means the process with the least arrival time will be swapped out in order to place page number 2 of process P1. Okay, that is what we mean by page replacement. Now, what do we mean by frame allocation? The number of frames which we are going to allocate for a particular process. For example, for process P1 we have taken that it is 3 frames, it is 2 frames, it is 3 frames, right? For process P3 we have assigned 3 frames. Now how will we decide how many frames should we allocate for a particular process? That is very important, right? Now why it is important? See, can I allocate more number of frames? You know that in case if I allocate 7 frames over here, because we have 7 pages, can I allocate 7 frames? In case if I allocate 7 frames, I am not using the concept of virtual memory. If I am not using, which means I am actually placing all the pages instead of placing only few pages inside the RAM, right? Because of this, degree of multi-programming will decrease and CPU efficiency will come down. So we will not do that. Now can we have only one frame? See, in case if let us assume we are assigning only one frame for process P1. In case if we do that, our degree of multi-programming will be very high, right? Because we are allocating only one frame for process P1, one frame for process P2, one frame for process P3. In that case, the degree of multi-programming will be very high. Fine, that is definitely true. But we might come across some other problem. Okay, that is what we mean by thrashing. We will see that what is meant by thrashing.